Hey everyone, we're here to look at your practice test for AP Statistics chapter 5. So we're going to go over about 4 of the answers here today, numbers 1 through 4. So the first one is the assignment of probabilities must obey which of the following. So we're going to go through each one of these and talk about true and false here. So first of all, the probability of any event must be between 0 and 1 inclusive, and that is true. You can't have a probability that's negative. You can't have a probability that's greater than 1. So there's no bones about it. Number 1 has to be true. Number 2, or letter B, the sum of all the probabilities of an outcome in a sample space must be exactly 1. And this is true as well. Now, this kind of supposes, of course, that all the outcomes means mutually exclusive outcomes. Now, if those outcomes happen to not be mutually exclusive, then this would actually not be true. But I think that's the reading that we're doing for this one. Letter C, the probability of an event is a sum of the outcomes in a sample space which make up that event. Now that, I think, on this reading is true. Because, again, we're saying that outcomes means mutually exclusive outcomes. So the sum of all the mutually exclusive outcomes would have to be the same probability as the event. So this time we're saying this is going to be all of the above. Now I know that the answer key probably says A or A and B only, but that's because on some other reading we were thinking that outcomes is not necessarily mutually exclusive. So really, depending on how you read outcomes, these may or may not be mutually exclusive, or the C may or may not be true. But I think that's not really going to happen so much on your actual test, so we're not going to worry too much about that. D, of course, should be correct here. Question 2 is a little bit more solid. Event A occurs with a probability of 0.2. Event B occurs with a probability of 0.8. If A and B are disjoint, which is to say mutually exclusive, find the probability of A and B and the probability of A or B. Letter B is probably easier here to explain, because we know for sure that if two probabilities or if two events are mutually exclusive, then the probability of A plus the probability of B is equal to the probability of A or B. Letter A is kind of weird for a lot of students, because for A, we're saying the probability of A and B, and a lot of students tend to mix up mutually exclusive and independent. So probability of A and B really gets to the heart of what it means to be mutually exclusive. Now, a mutually exclusive means that A and B cannot happen together. That's the definition of mutually exclusive. So by necessity, we can also say that, and I'm going to start typing here, but mutually exclusive is the same thing as the probability of A and B is equal to 0. They are the same thing by definition. So keep that in mind when we deal with things that are independent, because independent has a different rule for probability of A and B. Next we have number 3, and a fair coin is tossed 4 times, and each time the coin lands heads up. If the coin is tossed 1,996 more times, how many heads are likely to appear in those 1996 additional tosses? And the answer is, well, if the probability of heads is 50-50, or 50%, the answer is 50% multiplied by 1996. And that is 998 more times. Those first 4 times that the coin is tossed do not make a difference for the remainder of the tosses. In other words, the coin doesn't owe you 4 tosses. Doesn't owe you anything. Doesn't owe, just because it came up 4 times, that's not going to affect any future outcomes. So past outcomes do not affect future outcomes. The probability that the remaining 1996 will come up heads is still going to be 50%, regardless of what happened in the first 4 coin tosses. Finally, we have question 4, and a die is loaded so that the number 6 comes up 3 times as often as any other number. So what's the probability of rolling a 1 or a 6? Well, in order to figure out this probability, we're going to have to take a look at the probability distribution model for this event. So there are 6 possible outcomes, and they are numbered 1 through 6. Now, we don't know the probability of any of these, but we do know that they all have to add up to 1. So what we're going to do is we're going to say the probability of each of these is the unknown number x, because they are the same. However, the outcome for 6 has to come up 3 times as much as all the other numbers. So 6 gets triple the probability of all of the other outcomes. Now we're going to use the probability outcome, or the definition of probabilities, and we're going to say that all the probabilities have to add up to 1. By definition, all the outcomes, mutually exclusive outcomes, of course, have to add up to 1. And we have algebra for all of these probabilities. Completing the algebra, that looks like we have 1, 2, 3, 4, 5, 6, 7, 8x. So that tells me 8x is equal to 1, or x is equal to 1/8, which is 0.125. So now that I have that, I can actually complete this table and put the actual probabilities in. So the probability of a 1 is 0.125, and the probability of a 6 is 0.375. Now if I want to find the probability of a 1 or a 6, that's just equal to the probability of a 1 plus the probability of a 6, because 1 and 6 are mutually exclusive outcomes. So the probability of a 1 is 0.125, the probability of a 6 is 0.375, and that gives me a probability of 0.5. So that takes care of the first 4 questions on your practice test. Hopefully this is helpful to you, and I'll see you for the next set of problems.